Hi, my name is Hannah Edwards, and today I'm going to be talking about nucleophilic substitution reactions, the SN1 reaction. So, as we'll learn about multiple reaction types, we're going to need to be able to distinguish between types. So I'm going to talk about ways that we can readily identify if it's going to be an SN1 reaction or not, as well as ways that we can apply this to our everyday life. So, by definition, by Wade in our organic chemistry textbook, nucleophilic substitution reactions occur when a nucleophile replaces a leaving group off of a carbon atom, and the lone pairs of that bond are used to form a new bond from the carbon to the nucleophile. So we're going to explore some of the characteristics of the SN1 reaction through an example. So this reaction would follow an SN1 mechanism, and what we'll find is first, SN1 mechanisms favor polar protic solvents. So these would be something like methanol, water, ethanol, or acetic acid, which acetic acid is what we would use in this example. We also find that SN1 reactions favor tertiary carbons over secondary carbons, and they very rarely would occur on primary carbons. So this would fit that because the leaving group is on a secondary carbon. They also would favor weak nucleophiles like methanol, which we're using here, or water would be another example. So these characteristics can help us if we have a problem where we need to predict the products, that we can quickly identify that this would follow an SN1 mechanism. Now, as we look at what the mechanism actually goes through, the first step would be that the leaving group would leave. So in this example, the bromine would leave, and we would get a carbocation intermediate. And we find that this is another key point in SN1 reactions, is they go through a multi-step mechanism, unlike SN2 reactions, which happen in one step. So the carbocation is on a secondary carbon. We also find that SN1 reactions favor the most highly substituted carbocation intermediate. So we would want this positive charge to be on this tertiary carbon. So what would happen is we would perform a hydride shift, and the hydrogen would go into this carbon so that we can move positive charge to the tertiary carbon, where it's more highly substituted. Continuing with the mechanism, now we would be ready for the nucleophile to attack. So, in this step, the lone pair on the oxygen would attack the carbon with a positive charge, and the whole group would attach. So what we find is that the oxygen has a positive charge, which we don't want, so the last step in the mechanism would be that we would deprotonate, and we would use our solvent, which is acetic acid. Like this. And the lone pairs of the oxygen would attack the proton, moving this onto the oxygen, and we would get our final product. So what we will find is that mostly all SN1 reactions would follow a mechanism something like this. And another key point would be that SN1 reactions get inversion and retention of stereochemistry. So in a different example, we can see that. For example, we had a reaction like this, we would get a racemic mixture of both the inversion and retention product. And we would notice that stereochemistry only changes at the carbon where the nucleophile is attacking. So for looking at an example where we could apply this to health and wellness, we'll look at something that occurs in the body. Let me just draw the structure. So looking at this structure, this is a glucose linkage of cellulose, which we find in our bodies from foods that we consume like bread and pasta. And what happens in the body is that we cannot readily digest this as it is shown. So we need to attack, and we use water, which would be readily abundant. And in an SN1-like mechanism, the water would attack and break this carbon-oxygen bond, making something that the body could readily digest and that we could actually use for energy. So to conclude, we can see that we have a few key characteristics that we can use to decide if a reaction will follow an SN1 mechanism, and we can also conclude that we see it or use it in our everyday lives and our bodies. Thank you.